do the connected body problem, or this is also called pulley problem. So first we will see what are the assumptions which are generally taken while solving the Newton's law problem. So pulley is what? Pulley is something like something circular thing, and we have a string passing over it. So we have this kind of system. Okay, we have a pulley and we have two objects hanging like this. This is also called Atwood machine. Atwood machine. Another name for this system is Atwood machine. Okay, and what are the assumptions? So first we should know the assumptions which are used for pulley in the Newton's law chapter. So assumptions are, in many of the questions you will be provided the assumptions, but in many of the questions even the assumption is not written, but you have to assume these things because these are very common. It is assumed in every problem. So assumptions. First assumption is pulley is light. Pulley is light. So if pulley is light, you are not going to write mass of pulley. So masses of pulley will always be considered negligible mass. Second assumption is pulley is frictionless. The surface of pulley is frictionless. So what is meaning of frictionless? In next, when we will study the pulley in rotational mechanics, there we will assume the masses with the pulley, and we will also consider the surface of pulley is rough. But in this chapter, we consider it frictionless. So what does it mean frictionless? So if it is frictionless, the string can slide over it very comfortably without having any friction. So if you have two masses, suppose M1 and M2, suppose we have this kind of system and we have two masses M1 and M2. Suppose M2 is greater than M1. If the surface of pulley is smooth, the M2 can easily drag the M1 down. The friction is not going to stop this motion. There is no friction. The pulley is frictionless. So what we have to find? Find the acceleration of two blocks. Find acceleration of two blocks. Then we have to find, this is A, then we have to have tension in the connecting string. Tension in string. Tension in string. Then we have to find tension in the clamp. This one, the clamp which is hanging the pulley. So this tension also, suppose we write it T2. So tension in the clamp connecting pulley. Tension in clamp holding pulley. Okay, so these three things we have to calculate. So we are going to write the forces first. So first we will write the different forces what are acting on the two objects. So suppose the weight is M2, so weight will be M2G. The mass is M2, so weight will be M2G, and there will be a tension upward. So there are two forces acting. This object is not in contact with anything, so no contact forces, no normal, no friction. And here again, if it is M2G, and the tension here will be T1. Here it is T1. Both, see, this whole string is one single part. This whole thing is what? One single string. And there is no friction in between. So tension in the whole string is having only unique value. So in one string, you have only one tension. So the tension in the whole string is T1. So both sides it will be T1. Now we write the equation. We try to write the equation, and the equation for first we write for M2, equation for M2. Since M2 is heavier, it will go down, and M1 is lighter, it will tend to go up. And if M2 is going down with acceleration A, the M1 will go up with acceleration A. So we have first identified the forces, and we have drawn the free body diagram. Free body diagram we have not drawn separately. Here it is clear because All the forces are along the one direction only, and no need to take axis here, x y axis which we were taking, no need to take here because the motion of object is in vertical direction only. So no need to take the axis, no need to split the components. Okay, so we can directly write the equation. So M2G is downward, so M2G downward force minus tension upward force. The net force will be equal to M2 into A. So this is the equation for F equal to MA. This is the equation for M2. Similarly for M1, since M1 is going up, here it is M1. Since M1 is going up, so T1 will be more. So we will first write T1. T1 is more and M1G is less. So T1 minus M1G is equal to M1A. So this is equation 1, this is equation 2. If you add these two things, for solving, if you add these two things, we are going to get M2 minus M1 into G equal to M1 plus M2 into A. Adding these two. Add these two. Okay. So you are going to get A equal to M2 minus M1 into G divided by M1 plus M2. So this is the acceleration of the blocks. And for M2 it will be downward, and by the same magnitude for M1 it will be upward. You can also see if M1 would have been equal to M2, you can see M2 minus M1 will become 0. So in that case, if M1 equal to M2, these two will remain balanced. None of them will move. The acceleration will be 0. Okay. So next part we have to calculate tension in the string. So for tension in the string, we can use any of the formulas. So we use suppose first equation. So we can write M2G minus T1 equal to M2A, or we can write T1 equal to M2G minus M2A. So M2G and M2 and A is how much? A is M2 minus M1 G by M1 plus M2. So if you solve it, what you are going to get is it will be M1 M2 G plus M2 square G minus M2 square G plus M1 M2 G. So this much we are going to get divided by M1 plus M2. So what are the things which are going to cancel here? See, you can see this one will get cancelled and we are left with 2 M1 M2 G divided by M1 plus M2. So this is the tension which we are getting in the string. Tension is this much. Okay. Now, if this is the tension, what will be tension in the clamp, upper one? So for that, we can write the equation for pulley. You can see if we write the equation for the upper one, the upper pulley. For pulley, if you write the equation for pulley, if you write equation, there are two tensions which are acting downward, that T1 and T1, and there is one acting from upward. So T2 upward minus 2 T1 downward, and net force is 0 because the pulley is stationary and there is no weight. No need to write mass because pulley is considered massless. So only these two tensions are acting. One is T2 upward and second is 2T2, 2T1 downward from two sides, T1 here and T1 here. So T2 is double of T1. Mg we have not included, acceleration we have not included. Acceleration is not included because mass of the acceleration of the pulley is 0, pulley is stationary, and mass is also negligible, pulley is considered light. So mass is no, mg is not included. So 2, and how much is T? T1, that is 2 M1 M2 G by M1 plus M2. So how much we are going to get? We will have 4 M1 M2 G divided by M1 plus M2. So this is the tension in the pulley. Okay, so in this way we can find the tensions and the acceleration of the block.